From our morning coffee to our evening meal, climate change is slowly but surely altering how we eat and drink. Rising greenhouse gas levels from human activities like burning fossil fuels and deforestation are enhancing the greenhouse effect and causing global temperatures to rise. This disrupts normal climate patterns, resulting in shifting weather conditions that make it increasingly difficult to cultivate many major crops. Rising temperatures have significant impacts on agriculture, particularly in relation to changing growing seasons and crop cycles, increased heat stress on crops, and expansion of pests and diseases. High temperatures reduce soil water retention, preventing optimal crop development and affecting production levels. Furthermore, heat stress directly impairs crops' ability to photosynthesize, limiting their growth potential and diminishing yields. Consequently, workers may experience dehydration and fatigue, further reducing productivity and incomes. The agricultural sector also faces indirect effects of rising temperatures. Warmer conditions facilitate the spread of pests and diseases, compromising crop health and requiring additional resources for pest management. Moreover, elevated temperatures accelerate crop maturation, potentially shortening growing seasons. And crops may deteriorate faster before reaching grocery shelves, leading to financial losses and price fluctuations. Some specific examples of crops affected by temperature increases are peaches in Georgia and olives in Spain. In the summer of 2023, peaches in Georgia experienced issues due to unseasonal heat, which negatively impacted their growth and caused harm to the local economy. Similarly, olive crops in Spain have been negatively impacted by rising temperatures. In July 2023, dry weather in southern Europe damaged olive crops, leading to higher olive oil prices. Later, in October 2023, prices jumped 50% due to drought in Spain, record heat, and paused Turkish exports. Climate change's effects, including rising temperatures and precipitation changes, pose significant challenges to Spanish olive cultivation and olive oil production. These examples serve as regional illustrations of the broader trend of climate change affecting crop viability and agricultural practices worldwide. Erratic rainfall patterns and water scarcity can also significantly affect crops. Droughts can lead to water shortages, making it difficult for farmers to provide sufficient water to their crops, which can result in lower crop yields or complete crop failure, impacting farmers' incomes and food security. Additionally, during periods of drought, farmers may resort to unsustainable water extraction methods, further exacerbating water scarcity issues. On the contrary, excess rainfall and flooding can also negatively impact crops. Floodwaters can carry debris, chemicals, and pathogens that may damage crops or render them unsafe for human consumption. Moreover, flooding can delay planting and harvesting activities, reducing overall crop yields. Soybean, maize, and wheat crops have been significantly affected by changes in precipitation patterns. Increased heat and drought have negatively impacted crop production, especially in China, where drought and heat-resistant varieties of rice, wheat, and other crops are being developed. Similarly, a drought attributed to climate change and worsened by the El Niño weather phenomenon has negatively affected cash crops and staple foods, such as maize, in countries like Zimbabwe. Heat waves have also resulted in lower soil water retention, affecting crop growth and reducing worker productivity, leading to income loss and increased costs for animal care. Another challenge caused by climate change is extreme weather events. Severe storms can lead to flooding, which can damage crops and infrastructure. For example, a bomb cyclone hit California in early 2023, causing excessive flooding, affecting imports, exports, transportation, and damaging crops all over the state. Additionally, cyclones and extreme heat frequently hit certain regions, impacting crops and global food supply. Freezing temperatures can damage crops, especially those in vineyards and orchards, like nuts and berries. Entire trees and vines may need to be replanted, resulting in significant losses for farmers. For instance, a freeze in the second half of May 2023 damaged multiple crops, including strawberries and blueberries. Evidently, climate change poses a major threat to crop production, but ongoing efforts aim to mitigate these diverse impacts. Adapting crops to climate change involves two main approaches: genetic modification and traditional breeding methods. Genetic modification, despite its controversy, offers potential solutions by altering plant DNA to introduce desirable traits. In June 2023, the European Union lifted certain restrictions on genetically modified crops to aid farmers facing climate challenges. Another approach is through traditional breeding methods, which involve selecting and crossing plants with desirable traits to create new varieties. This method is generally viewed as safer and more sustainable than genetic modification, albeit time-consuming, and may not always result in the desired traits. Sustainable farming practices that can help mitigate climate change include water conservation, crop rotation, and the promotion of biodiversity. One such practice is the implementation of no-till farming, which involves leaving crop residue on the soil surface rather than disturbing it through plowing. This method helps retain soil moisture, reduces erosion, and fosters the growth of beneficial soil organisms. Additionally, planting cover crops during off-season periods can enhance soil health, suppress weeds, and minimize water runoff. Furthermore, integrating crop and livestock systems can promote synergies between these components, enhancing overall productivity while reducing environmental impacts. Precision agriculture and technology play a vital role in combating climate change through several strategies. These include utilizing advanced sensors and IoT devices for data-driven agriculture to monitor plant care, fertilization, and harvesting for high-yield crops. Implementing AI and automation in agriculture can promote sustainable resource management, such as monitoring crops and optimizing water usage, especially in areas affected by climate change. Reviving ancient agricultural practices, such as the use of biochar and compost, can contribute to healthier soils, increased crop yields, and reduce dependence on fossil fuels. Lastly, encouraging advancements in precision breeding can result in crops that require fewer pesticides, are more resistant to diseases, and perform better during extreme weather events. In the face of climate change's threats to agriculture, adaptation is essential. Developing resilient crop varieties, practicing sustainable farming, and leveraging technology are crucial steps. With international collaboration and innovation, these challenges can be overcome, ensuring food security and a sustainable future.